That keeps warm. Alright, today we are going to start talking about segment proofs. Okay? We're going to start talking about segment proofs. So when we did the algebraic proofs, we talked about all of these different properties. Okay? We're still going to use some of these as we get into geometric proofs. Right? The addition property just means I can add the same thing to both sides of an equation. Right? Same thing for subtraction, multiplication, and division. Distributive property, okay, we know what that looks like. Right? If we have something like this, I can distribute this A through the parentheses. Okay, substitution. Okay, we know that if we have two things that are equal, I can replace one thing with the other. And we also talked about reflexive. Okay, that's where something is equal. Okay. Reflexive, that's where something is equal to itself. Symmetric, we can flip things across the equal sign. And transitive, if two things are equal to the same thing, they're equal to each other. Okay? So we talked about all those before. We're still going to use all of those. All right? So having that other reference sheet that we used when we did algebraic proofs would be a good idea. Okay? So we're going to start looking at properties of congruence today as well. Okay? These are that we looked at for quality. Okay? But now we're going to apply them to segments. So if I have some segment, AB, the reflexive property tells me that that segment is congruent to itself. Okay? Now, I guess we should make a distinction here. Okay? When we use a congruent symbol and when we use an equal sign. If I'm talking about lengths of segments, okay, lengths of segments are equal to each other, right? So I would use an equal sign. The way we denote a length of a segment, okay, if I'm talking about segment AB, I would just say AB, okay? If I'm talking about the segment itself, okay, the geometric figure of the segment, okay, segments are congruent, okay? And the way we denote a segment is a line over top of it. So the lengths of segments are equal to each other. The geometric figure of a segment, okay, we say those are congruent to each other. So these properties of congruence, okay, our correct notation is going to be the lines over top and the congruent symbol in between. Okay, the symmetric property says if I have two segments that I know are congruent to each other, right? So like AB is congruent to CD, then I can flip them across the congruent symbol. So CD would be congruent to AB. Okay, same idea as the symmetric property when we looked at equality. Right? Just I can flip things across the equal sign, or I can flip things across a congruent symbol. The last one up here, the transitive property. If I have AB congruent to CD and CD congruent to EF, right? So both AB and EF are congruent to CD, then they would be congruent to each other. Right? So we can say AB is congruent to EF. Right? Now, the next two are definitions. Okay? Just a definition of congruence and a definition of midpoint, right? Oh, wait a second. Everybody gets this copied down. So our two definitions here. Definition of congruence is just if I know two lengths of segments are equal. Right, so if I know that the length of AB is equal to the length of CD, then I can say that the segments themselves are congruent. Then their lengths are equal. Okay, so again, the notation here is talking about the segments themselves, the geometric figure of a segment. Here we're talking about the length of that segment. Then the definition of a midpoint just says, well, if M is the midpoint of AB, right? So let's sketch this out, right? So we've got M is the midpoint of some segment AB. If I know that's the case, then this larger segment is split into two congruent or equal parts. Okay? So if I know M is the midpoint of AB, then I can say that the length of AM is equal to the length of MB. Right? These two smaller segments would have the same length. Okay, so we talked about that a little bit when we talked about midpoint in the first chapter. Okay, and then the final one that we're going to look at is a postulate. Okay, a postulate is just something that we take to be true. So the segment addition postulate, and this is, again, actually something we've already looked at. Okay, we're just going to use it now to prove things. The segment addition postulate just says if I have some segment, okay, I've got 3 points on this line here, then I can say, well, this piece plus this piece equals the whole thing. Right? So we can say AB plus BC equals AC. And we worked on that in the first chapter. We set up equations and solved for variables. Okay, now we're going to use these ideas more to prove things. Okay? So any questions on these definitions, properties, postulates? All right, so on the back then, we're going to take a little bit of time to make sure that we can recognize these properties. Okay? So we're going to take 10 or 15 minutes here, and you guys are going to work through and try to recognize these properties. Now remember, okay, I mean, you've got your list of all the possibilities down at the bottom. Okay, addition, subtraction, multiplication, division, those things are going to show up again as well. Okay, as well as the other ones that we just looked at. Okay, so let's take a few minutes here, okay, and try to match each of these statements with what property is being shown. All right, let's go through these together here. So, the first one, okay, if I have two lengths that are equal to each other, then I can say the segments are congruent. That's definition of congruence. Right. The second one, if K is between J and L. Okay, so it's always a good idea to sketch out what the statement says, right? So you can visualize what's happening, right? So it's just saying K is somewhere between J and L. Then they say JK plus KL equals JL. That was our segment addition postulate. Okay?
Oh.
Right? The third one, if I'm just saying that something is congruent to itself, that's the reflexive property. TU, then RS plus XY equals TU plus XY. So we're thinking about, this is the first step of an equation. To get to this step, what they did was add the same thing to both sides of the equation. Okay, so if I'm adding, that would just be the addition property. Number 5, all they did was flip things across the equal sign, right? If AB equals DE, then DE equals AB. That's the symmetric property.
I always think of it as the switcheroo, like the S from switcheroo to the S to symmetric, because you're just switching them. My own nerdy little way of remembering it.
Okay, that works. 6, if y is the midpoint of xz. So again, let's sketch that out. Okay, so we're saying y is right in the middle of x and z. Well, then they say xy equals yz. That's just our definition of a midpoint. And if I know that something is midpoint, that cuts the segment exactly in half. So this one would be def of midpoint. Now we've got if FG and HI are congruent, and HI and JK are congruent. Okay, so we're saying that FG and JK are both congruent to the same thing, then they're congruent to each other. That's the transitive property. Number 8, again, we've got an equation here. So if AB plus CD equals EF plus CD, then the second line of the equation, those CDs disappear. Right? So what they did was subtract CD from both sides of the equation. Okay, so this would just be the subtraction property. Number 9, okay, this one's kind of a longer one, so let's try to decipher what's going on here. If PQ plus RS equals TV, and RS equals WX, then PQ plus WX equals TV. So if I look at these two equations, the only thing that changed was RS changed to WX. Okay, well, I was just told that those things are equal. So if they're equal, I can replace one with the other. That's the substitution property. Then number 10, I've got LP equal to PN, and LP and N are collinear. So that's a lot going on. Let's sketch that out. So we've got LP and N are collinear. So LP and N are collinear, and LP and PN have the same length. Then P is the midpoint. Okay, that's also going to be definition of midpoint. Okay? It works both ways, right? We can say if I know these are equal and they're all on the same line, then P has to be the midpoint. So def of midpoint. 11. If I know that two things are congruent, then their lengths are equal. That's our definition of congruence. And the last one, if CD plus DE equals CE, then CD equals CE minus DE. So again, we're thinking about this as the first step of an equation. How do I get to the second step? Okay, well, what changed? Well, this plus DE is now over on the other side as a minus DE. Well, to do that, okay, we would just subtract DE from both sides of the equation. When I do that, these would cancel out, and I would just end up with CE minus DE on the other side. So this would be the subtraction property. Okay. Any questions on recognizing these properties?
Will we have this
On test? No.
No. I'll use it as a work or something.
Yeah.
It's gonna show up a lot.
Yeah. That's why we have this. We're gonna work with